Okay, it's time to start. You are very welcome to this session, Design Process Transformations for Industry 4.0. And my name is Åsa Ericson, and I'm a professor in information system at Luleå University of Technology in Sweden. My research interest is within product service system, and digital transformation and industry 4.0 is quite wide. And and that's all about me. So we will start this session with looking at all the pre-recorded presentations, and Robert the helper will help us with showing them. And you should keep your audio and FaceTime sharing muted while we are looking at the video, I think. Or you can mute it. But I encourage all to write down questions in the chat for each presenter. Just remember to write the name of the presenter you are addressing. So Robert, should we start looking at the videos?
Yes, okay.
Thank you.
Hello and welcome to my presentation. My name is Jakob Trauer, and today I'm going to present to you the results of our project together with Siemens on how to create trust in digital twins. But first, let's start with the motivation and goal of the project. Over the last decades, the number of digital twins has been increasing. And in future, ecosystems of digital twins with a wide variety of stakeholders are going to evolve. Also, as digital twins are meant to cover the entire life cycle, an inherent characteristic is their interdisciplinarity. So a lot of different parties, companies, and stakeholders have to collaborate when creating a digital twin. First, technical formats and interfaces for exchanging digital twins are already known. However, one of the major factors impeding the implementation of digital twins is setting realistic expectations and trust. So digital models and digital twins are not really trusted, especially not if the partners hardly know each other. So the goal of our project was first to derive a definition for trust in the context of digital twins, and second, to develop an initial framework providing recommendations and insights from research and the state of the art on how to create trust in digital twins. Our research was based on two pillars, an interview study and a market research. For the interview study, we invited 10 industry participants out of 9 companies, covering a broad range of industry. All of them had experience in digital twins, digitalization, or trust. And quite interestingly, most of them stated that their colleagues had distrust in digital twin in the past, and also that most of themselves distrusted digital twins in the past. For the market research, we analyzed the most common software stores, so Google Play, Apple App Store, Steam, Microsoft Store, Amazon Marketplace, and Mercator. And from this market research, we were already able to derive some basic measures on how to create trust in digital twins. So these two pillars led to our digital twin trust framework, which consists out of 3 main parts: the stakeholders, the user stories, and the solution elements with its concrete measures. For the stakeholders, we identified 3 main parties. First, the digital twin supplier, so the party who creates the digital twins, who is developing it. Then the user of the digital twin, who pays the supplier for the digital twin and uses the digital twin in the end. And then you have a large variety of different partners of the users, which are collaborating with the user and thus are interacting with the digital twin. For the user stories, we identified 9 user stories, which are basically the combinations of the different stakeholders, so how they are interacting with each other. And at the core of our framework, we have the 7 solution elements. So how can you create trust in digital twins? First, you should explain your twin properly, so that everyone has the same understanding of what a digital twin is, and also that everyone has the same expectations on what the digital twin can do. Second, you should create a common incentive By doing so, you can show that you are also interested in a high quality and a high fidelity, high trustworthiness of your digital twin. As digital twin projects are usually quite large and fuzzy and complex, make sure to take only one step at a time to not lose anyone on the path of getting there. A must-have for all digital twin projects, of course, is to protect the IP and to ensure safety. So have nice IT safety protocols, have virus checks implemented, so you can show that you are protecting the data. But also prove your own quality. So show using best practices, ratings, rankings, customer experiences, that you are a trustworthy partner and that it's worth collaborating with you. When you're implementing the digital twin, then ensure a uniform environment. So use one coding language or environment, use building blocks so that all people can understand what the digital twin is doing. And last but not least, document thoroughly. So this is our digital twin trust framework. To further increase the applicability of this framework, we also derived one-pagers for each of these elements. So for the stakeholders, for the user stories, for the solution elements, and also for the concrete measures. So what did I show to you today? First, trust in digital twins is lacking and prevents them from further application in industry. Second, we've shown you the main stakeholders, which are the digital twin supplier, the user, and the partners of the user. And last, I've shown you the digital twin trust framework with its 9 user stories and the 7 solution elements. We also conducted an initial evaluation together with our partners from Siemens, which shows medium to high level of applicability and usefulness. Shortcomings here are the lack of implementation, the missing quantitative metrics to assess trust, and also some ready-to-use elements on how to improve trust in digital twins. So what are we going to do in the future? First, of course, we're going to set up a use case for pilot implementation, then the development of quantitative metrics to assess trust is required. And last but not least, of course, the goal of this project is to design a platform offering digital twin building blocks, including trust measures. So that's it from my side. Thank you very much for your attention. And now I'm very much looking forward to our discussion.
So we will show the next video, Robert.
Thank you for the opportunity to present our extended abstract on design theory in support of Industry 4.0 management. We are a mixed research group coming from Management Department of the University of Turin and Université Paris-Saclay, Centrale Supélec, Laboratoire de Génie Industriel. Our research focus on Industry 4.0 or Fourth Industrial Revolution started in 2011 to promote competitiveness and productivity of manufacturing firms, mainly through technological adoption. However, despite the adoption of 4.0 technologies, the strategic organization of many firms remains obsolete. For this reason, the aim of our research is to explore new ways to sort out the unknown phases of Industry 4.0 to fully realize the transition to the Fourth Industrial Revolution by reducing uncertainty, being generative, and aligning technology's knowledge structure with such as space, institutional rules and cultures, and creating the right ecosystem. For this reason, we suppose that design theory may be the right solution to improve Industry 4.0 implementation and management and performance. So our 2 research questions are: can design theory be useful to improve Industry 4.0 adoption, and how it may be useful? The theoretical background distinguishes the known aspects of the Fourth Industrial Revolution and the unknown phases of this revolution. The known aspects are that 4.0 technologies adoption leads to greater performance, and this is positively mediated by public and private incentives. This is also mediated by barriers that may impact in a positive or in a negative way on performance, depending on the readiness of firms to manage these barriers. Finally, 4.0 technologies adoption leads to greater complexity. Industry 4.0 systems are 70% complex than traditional systems. This might lead both to greater or fewer performance, depending on the readiness of firms to manage this complexity. By the other hand, the unknown aspects of the Fourth Industrial Revolution are that Industry 4.0 and the most recent concept of Industry 5.0 introduced by the European Commission require to reinvent the role of humans in the factory. And this new role of humans might be reinvented by design. For this reason, the methodology adopted is a theory-based literature review on design theory in the field of Industry 4.0 to identify three goals. So, to identify theoretical foundation of design theory for technological innovation, to search the most useful and feasible frameworks to apply design theory in practice, and to discover eventual existing application of design theory on Industry 4.0 systems. Our descriptive findings are that only 10 papers in the industrial engineering and management literature identify possible connection between design theory and Industry 4.0. Moreover, articles explicitly focusing on empirical application of design theory for Industry 4.0 are lacking, and the majority of identified articles is focused on industrial application of design theory in certain types of business functions, such as only on product design, or in certain technologies, such as only in additive manufacturing or cyber-physical systems. The thematic findings are that design theory may help firms to overcome the recurrent tension between perseveration and innovation, showing whether Industry 4.0 adapts to existing rules or require new rules. We know that Industry 4.0 involves more difficulties in managing complexity for SMEs than for large firms. So we might suppose that Industry 4.0 only fits locally with existing rules. But we also know that micro firms paradoxically get more benefits from adopt Industry 4.0 than larger firms. This might suggest that this is a solution that changes depending on the context in which it is adopted, and it has excellent potential in each of these contexts. Finally, all firm types report difficulties in dealing with barriers and complexity coming from Industry 4.0. So this might show that Industry 4.0 is an innovation that generally does not fit within existing rules. So we can assume that Industry 4.0 requires a mix of these three solutions, depending on the specific rule system, on the specific firm's characteristics, and or on the different technologies adoption. This new approach might help in the transition to the Fourth Industrial Revolution, not only by adopting technologies, but reinventing new uses of the technologies, enriching the interpretation of the concept of performance, barriers, complexity, incentives, and so on, and transforming these concepts into drivers for the success of Industry 4.0 adoption. With these results, we propose a research framework adapting design theory and empirically adapt this theory to industrial context and Industry 4.0 systems. We identify CK model as the best tool to adapt design theory in Industry 4.0 system, and we propose as research methodologies a collaborative management research methodology based on a comparison between 4 single case studies distinguished for firm size and technological intensity of the industry. So big companies of high-tech industries, big companies of low-tech industries, small companies of high-tech and low-tech industries. The main contribution of this research is to integrate the literature on industrial engineering and on design theory with the management literature to open up new research lines on Industry 4.0 implementation. This might help academics, policymakers, and managers to identify the best solution to profit from the fourth industrial revolution. So thank you very much to discuss with us this proposition, because our extended abstract is not only a concluded research, but is only a proposition to be discussed with you. Thank you very much for your attention.
Hello, my name is Matthias Guertler, and today I'd like to present a joint paper on a life cycle framework to manage collaboration and knowledge exchange in open organizations. So what's the underlying background and motivation? We can see an emerging trend towards medium and long-term types of open collaboration and innovation, for example, in terms of triple or quadruple helix innovation ecosystems, startup ecosystems, or virtual organizations. A specific type here are university industry research centers, which are highly interesting from an overarching research perspective, because they're interdisciplinary, often triple helix focused, meaning they combine academia, industry, and government perspective. They not only focus on exchange of knowledge, but also an exchange of knowledge carriers, meaning that we can, for example, have researchers moving between universities or from academia to industry. Usually, they are also medium to long-term oriented, and depending on where you're from, this might range from 5 to 12 years. But we can also see that the needs of such an organization change quite dramatically between the different life cycle phases. This leads us to the question, how can collaboration and knowledge exchange be systematically managed over the life cycle of an open organization? In order to answer this question, we picked a case study object, in this case, the Australian Robotics Centre, which is a suitable object because it's sufficiently complex. So we have 21 researchers plus 5 postdocs plus 16 PhD students, which are structured in 5 research programs, which 3 to 4 projects each. In addition, we have several industry translation projects, and in total, we have 4 universities involved, including different departments, schools, and centers, as well as 6 industry companies, including 1 industry association. And we also have a defined end of life, because the funding ends after 5 years. And this, for example, is a little bit a difference to an industry-oriented organization, which normally tries to live as long as possible. But this allows us really to analyze all life cycle phases of such an organization. The key underlying models we are using are an open organization model, because it allows us not only to look at the knowledge which is exchanged, but also the knowledge carriers. And it also allows us to structure our organization and look at it from different perspectives. So we can have a network, a company/organization perspective, as well as a department perspective, which, for example, nicely reflects on the university structure. We also have a 5-phase organizational life cycle model, which allows us to analyze an organization life cycle based on 5 phases. We have a birth phase, a growth phase, maturity phase, revival phase, and a decline phase, where we either close up our research center or we have some kind of legacy, for example, when researchers move to a new research center or knowledge is carried over to another research center. And of course, we also have other theories like open innovation or university industry collaboration. So we used all of these approaches to develop an open organizational life cycle framework. So on the x-axis, we have the different life cycle phases, and on the y-axis, we have different relevant elements, which allows us to describe each of the phases. So the first one describes the purpose and the goal of our life cycle, the different life cycle phases. The second category looks specifically at the performance. Here, for example, our research performance or the performance of our industry translation projects. The third one looks at which key activities do we need in order to enable and support the achievement of the goals of each life cycle phases, as well as what are the key challenges preventing us to do this. And we have a category specifically looking into collaboration and knowledge exchange, and what do we need in each of the phases in order to achieve our goals. And the last category are specific activities which can help us to build, strengthen, and support the knowledge exchange and the collaboration in each of the phases. So if we look at the first phase, the birth phase, and only in the collaboration aspects and ignore everything else, we can say the first phase, for example, is about exploring research interests and practice interests in order to map them onto each other and really make sure that the knowledge exchange and collaboration can happen in a systematic, purposeful way. And for this, we need to, for example, clarify the research programs, identify synergies between them, and also map them onto our translation projects. So example activities we conducted in this phase are that we clarified the research programs and interests. So here we checked that everything was still up to date, because there was a delay of 2 years between the submission of the proposal and the approval of the center. So in the interviews and focus groups, we discussed them with the different program leads, and we also derived a list of key topics for each of the projects, which then supported in the next step the mapping of research programs and industry translation projects. And here we used the domain mapping metrics and mapped research projects onto industry translation projects. And here, for example, we can also use some simple metrics. For example, if we look at the column sum, we can see how many different research projects do I need in order to enable one translation project, which might be an indication for the complexity of a specific translation project. We can also look at the row sum and identify particularly popular research projects, which might need additional resources to really fulfill the demand. But we can also identify underutilized research projects, which might need more promotion, or where we can also discuss if we might pivot them to a slightly different topic. So to conclude the presentation, we can say that we have an emerging trend towards medium and long-term types of open collaboration and innovation. And we can also see that we have different organizational innovation management needs depending on the life cycle phase of such an organization. Our paper contributes to the body of research by combining an open organization with an organizational life cycle research perspective. And a university industry research center is a particularly interesting case study because it has a defined end, so it will allow us to analyze the entire life cycle. But our insights are also useful for industry settings and allow us to plan and manage temporary open organizations. The next steps include, since the current research is conceptual and mainly literature-based, we need to add some empirical parts. So, for example, some interviews and surveys to capture previous experience with research centers, as well as interests and needs concerning our current one. Plus a frequent survey, for example, on a monthly basis to capture the evolution of collaboration, knowledge exchange, as well as the satisfaction and open-ended feedback, so we can really track the evolution. But it also allows us to identify issues in a timely manner and allows us to react to them. And of course, we also want to further enhance our framework and supporting method and tools. And we also want to evaluate framework and method and tools by using action research evaluation. Thanks for listening to me. And if you want to learn more or know more about it, just get in contact with me.
Hello, I'm Dr. Ross Brisco from the University of Strathclyde's Department of Design, Manufacturing and Engineering Management, and today I'm going to tell you about my paper on understanding Industry 4 digital transformation. In response to prominent calls in 2019 from the likes of Forbes, Institute of Mechanical Engineers and the Scottish Government, a CPD course was envisioned to support strategic technology selection for Scottish engineering companies. Surveys determined a lack of foresight for digital transformation in business leaders, particularly when the number of digital natives within companies increases year on year. This was identified as a strategic development opportunity, and 6 questions were created to support Scottish engineering companies to begin their digital transformation. These all led on to the development of a CPD course in strategic technology selection. Digital transformation is an ability to change when opportunities arise or are needed, using technology as a means. From our literature search, we then determined that we would investigate how best to educate Scottish industry in the potentials of Industry 4 within engineering at a range of sizes. There are many advantages of Industry 4 that have been well documented in the literature. However, what we saw as the barriers to this project were the barriers to digital transformation. These included capacity to change, culture which encourages change, knowledge of how to change, and justification for change. And so it became that we investigated better education on Industry 4 potentials and how to evaluate and implement these potentials. The methodology selected for the research approach was the development of a CPD course in strategic technology selection, the design of an activity to support digital transformation project planning, and to analyze the outcomes of the planning activity to determine digital transformation readiness. 4 companies took part in the workshop. Company A is a multinational aerostructures manufacturer operating across 5 countries and supplying the big 2 aircraft manufacturers with fuselages, wings, and other components. The company has between 15 and 20,000 employees worldwide. Company B is a multinational naval and maritime manufacturer operating across 10 countries in 4 key areas of marine, nuclear, land, and aviation, with around 35,000 employees. Company C is a medium-sized manufacturer of fishing products based in Scotland, including rods, poles, reels, and other accessories. The company has an average turnover of £20 million. And Company D is a small design and product development company based in Scotland with one cycling accessory product in retail. The company has less than 5 employees. Towards the development of the project planning activity and to encourage collaboration between delegates and promote multidisciplinary inclusion in digital transformation, an activity was envisioned and a template was created to guide delegates to make a full consideration of the new system, including defining the scope and boundary of the system. The digital transformation planning activities were conducted by the teams. You can see some of the examples here that are included within the paper in full. The outcomes of the activity provide insight into the company's understanding of Industry 4 and attitudes towards digital transformation. Comparing the roadmaps for each company, the larger companies A and B had a greater understanding of Industry 4 and how to enact change. Delegates from these companies highlighted the need to establish KPIs, implement the company's phase gate process, and to hand off the project to a continuous monitoring team. Each of these interventions indicates already established change management protocols within the company. In comparison, the smaller companies, C and D, had a focus on turnover, including make-buy analysis, customer specification, and technology as defined by the budget. Delegates from the larger companies had a mandate for continuous improvement and used Industry 4 to move towards a more productive state. Those from the smaller companies were more focused on day-to-day activities and could only justify improvement if it were required for a future project or if a supplier demanded change to integrate with their system. This puts a disadvantage on smaller and medium-sized enterprises located within Scotland who cannot grow, limited by their competitive position. Another finding which matches this sentiment is the identification of future-proofing by companies C and D. The terms used within the activity indicate that there is a need to be a minimum viable use of technology to justify its purchase, i.e., it will remain relevant for 10 years. With the speed of technology change, this is perhaps not guaranteed by Industry 4, which seeks continuous improvement. Again, this puts smaller companies at a detriment. All companies highlighted that there is a need to identify available funds for budget approval. However, the smaller companies framed this in the perspective of return on investment. When implementing new Industry 4 technologies, the purpose may be to justify more productivity and therefore a fast return on investment. However, the motivation for a move to Industry 4 may not support a productivity increase and may be motivated by outside demands. This means that a return may not be achievable in the short term. Company C confirmed that they are focused on measurable improvements that can be justified to customers and were beginning in their transformation. However, many of the interventions identified could perhaps be classified as Industry 3.5, somewhere between Industry 3 and 4. Larger companies were very aware of what Industry 4 is and the types of digital transformation interventions that they could implement. Road mapping at a company-wide level supports strategic planning. However, individual interventions are difficult to envision, which the project road mapping activity was able to support. The outcomes of the road mapping activity reveal the Industry 4 understanding for each of the engineering companies at different sizes. Future CPD courses will allow the findings to be confirmed and generalizations to be made. Thank you very much for listening, and I look forward to your questions.
Hello everyone, welcome to the presentation of our research paper, Identification of Human and Organizational Key Design Factors for Digital Maturity. We present a fuzzy set qualitative comparative analysis. The authors of this paper are Professor Schneider, Talea Helwig, and myself, Jörn Steffen Menzelfricke. I will introduce the topic and present the data set. Then Talea will present the method we use as well as our results.
Companies are trying to leverage the potential of digitization by introducing different use cases. For example, smart services, simply assistance systems, virtual and augmented reality applications, or, for example, driverless transport systems can be stated here. However, digital maturity is not only reached by technological achievements, equally, changes must also take place on the part of the organization and the employees in order to increase digital maturity. However, which organizational and human factors are relevant for increasing the technological maturity of companies is discussed in very diverse ways. As an example, the structuring approach of Hopf et al. Has been presented here, in which the dimensions are divided into different components. Some approaches in the literature state that the dimensions of human and organization with their characteristics are to be adapted equally. We will refer to this as the maximalist approach in the following. Populus and Röcklinger, as well as Bühr et al., provide opposing approaches. They say that the combination of individual factors from the human and organizational dimensions is promising for positively influencing the digital maturity of companies. We call this the configurational multiplicity approach. In this article, we distinguish between the digital maturity of products and the digital maturity of productions. But which factors are actually relevant in these dimensions of human and organization to increase the digital maturity? This brings me to the objective of our paper. We want to investigate how the human dimension and organizational dimension influence the technological maturity with different factors. To this end, we have analyzed the factors job autonomy, participation, training, and variety in the human dimension. And in the area of organization, we analyzed the company size, the presence of a customer-oriented innovation strategy, and the presence of an entrepreneurial culture. We defined the outcome as the degree of digital maturity of products and production. We used the results of an online survey conducted by the research project in Luleå as a data set. Company representatives were able to assess the digital maturity of the company on the basis of 33 criteria in the dimensions of human, technology, and business. The previously mentioned criteria, such as job variety and autonomy, are part of the evaluation criteria. The dataset comprises the responses of a total of around 110 responses, and my colleague Talea will now present the method and results.
Thank you, Steffen. I will start with the presentation of the method. For the analysis, we use the FS-QCA method. The QCA looks at which configurations of different factors lead to a certain outcome, in our case, a high level of digital maturity. In order to do so, it uses the logic of set theory and Boolean algebra. In this small example, we see different values for training, participation, and the degree of digital maturity. A value of 1 represents a high level and 0 a low. Training and participation could be important factors for achieving digital maturity here, as both values are high in companies 1 and 2, and these companies also have a high level of digital maturity. Now it is important if this pattern is repeated in other observations too. The QCA method examined how often and how consistently a combination of factors is associated with a high level of digital maturity. Precisely, we carried out the QCA in 2 steps. In the first step, we analyzed which organizational factors are sufficient for achieving digital maturity, and the analysis revealed two important organizational contexts. First, an entrepreneurial spirit alone was found to be sufficient for technological maturity. And secondly, also large firms that strongly pursue customer-oriented innovation often have a high level of digital maturity. In a second step of the QCA, we took the previously identified companies and examined which human factors are relevant for achieving the digital maturity. In this table, we saw important combinations of variables that are found to be sufficient conditions. The results are separated by digital maturity of the product in the left table and the production in the right one. We find that there are very different paths to success for different companies. However, one path stands out in both cases, and that is path 1, as it is most frequently observed and is identical for both product and the production. It says that training and employee participation is a sufficient combination for achieving digital maturity. Combining the results of the human with the organizational conditions, we find two success paths. First, intensive training and strong worker participation need to be combined with a strong entrepreneurial culture. And second, the two human factors need to be combined with strongly customer-oriented innovation in larger firms. Various possible conclusions can be drawn from these findings. For example, smaller firms can achieve technological maturity when they practice a strong entrepreneurial culture. And intensive training and strong employee participation are frequently combined in firms achieving technological maturity. Note that the maximalist hypothesis does not contradict the new one, as it is a subset of both success paths. All in all, we see that the QCA has proven to be highly suitable for the empirical analysis of such kind of data and can accordingly be used to identify key factors and their combinations. This paper focused on one particular digital maturity model. Further studies should extend the analysis to other studies from different contexts and with possibly larger sample sizes.
So thank you. That was all of your nice movies. May I ask you to share your audio and faces again, the presenters? I think also you might already have noticed that I use this Swedish tradition since I think it started in 1963. So we just use the first name of each person. So I will let you experience a bit of Swedish tradition. But I think it would be nice if you as a presenter can present yourself very briefly. So I will start with Jakob.
Yeah, hello. So my name is Jakob. I'm a research associate at the Laboratory for Product Development and Lightweight Design at the Technical University of Munich, now for 3.5 years. And my background is mechanical engineering, but now I'm predominantly focusing on how to implement digital twins in companies of all sizes and how to support them in this difficult task.
Yeah, thank you very much. And we continue with Rebecca.
Hello, everyone. I'm Rebecca from Italy, from Turin. I'm working as postdoctoral researcher in management, but I have done a PhD both in management and in industrial engineering in Paris at Centrale Supélec. And so my research topic is Industry 4.0 and how it increases performance in manufacturing firms.
Thank you very much.
Thank you.
Matthias.
Hi, I'm Matthias. I'm a senior lecturer at UTS, so University of Technology in Sydney. I'm a researcher at the interface of product development and manufacturing. So specifically, how do we adjust engineering design in order to support the adoption of Industry 4.0 and vice versa?
Thank you very much. And Ross?
Hi, I'm Ross from the University of Strathclyde in Glasgow, Scotland. I finished my PhD last year on computer-supported collaborative design. I work closely with the Collaborative Design Special Interest Group of the Design Society. And also my other interest is in design education, and I help with the ENPD conference each year with that. So yeah, open to some more discussions about that throughout the week.
Thank you very much. And Jörn, are you Jörn or are you Jörn Stefan?
All right, thank you. Yeah, please call me just Stefan.
Stefan, okay.
Yeah, I'm a research associate here in Paderborn at the Heinz-Nixdorf Institute of the University of Paderborn. My background is also mechanical engineering, and yeah, I'm working at the Department of Advanced Systems Engineering, and our research field focuses the strategic planning and all their activities for business development in context of digital transformation, such as business models and technology management that are the focuses of our research.
Thank you. You don't have Talia with you?
No, sorry.
Oh. So that's your co-author or co-presenter at least. So we have heard her voice. So I think I have, or I know that I have questions for each one of you. And you will notice that I ask of curiosity because I like to learn more about your papers and your research. And you will also notice that sometimes I even think while I'm speaking. So, I mean, there's nothing right or wrong. It's just that I would like to know more. But I will start with Jakob again. And I have to tell you that I have a background in system science. And the word system is really a problem for me. So I usually don't understand it. But you say that the digital twin is you define it in the paper as a virtual representation of a physical system. And to me, a physical system is a car with its like a coffee machine or assembly of physical parts, objects working together. And then I come to think of a CAD model, computer-aided design model.
Mm-hmm.
Like, can you help me to understand your digital twin better? Because you also said that you have to explain your digital twin so everyone knows what it is.
Yeah. So from our perception, a digital twin is a quite broad term because you have quite different possible applications of digital twins. So we try to focus on the core elements of digital twins, the core characteristics. So what do you need to have? You need to have what we call the physical system. So you need to have something in the real world which you can observe, where you can collect data. That might be a car, it might be a coffee machine, but it might also be a production line. It might also be maybe even an organization. And then you want to represent this real world aspect in a virtual model. This virtual model, of course, could be a CAD model. It could be a simulation model. It could also be more or less a database. And what is then really important is that we do not only want to collect the data, so we don't only want to have monitoring systems, that would be a digital shadow, but we also want the digital twin, the virtual system, to run simulations, to run predictions based on the data, and to also influence, again, the physical, the real world aspect. So for example, you could collect data from a production line, you analyze it, you could find anomalies, for example, and then extract parts from the production line where you had failures, and that should be automated. So this was our idea behind the definition.
Maybe you noticed that I skipped your. You had a second part of the definition stating something about the life cycle.
Mm-hmm.
And but now I start to understand it's the life cycle of the data for the thing or the process that you are using in the digital twin.
Yeah.
Sort of. You also say that it's a lack of trust in digital twins. And I mean, what's the... I think also there's a difference between lack of trust and distrust. I don't know, but it's just how it feels for me. But what is the reason for this lack of trust? Because it's a model. It's not the blueprint of a real world.
Yeah. So I think, first of all, the observation at the beginning was that this concept of digital twins is known for quite a long while now. And right now, if you look, for example, at the Gartner hype cycle, it had already its peak 1 or 2 years ago, and now it's sliding in the valley of through. Companies are struggling to implement digital twins, and I think this is similar to other innovations, to other, especially digital innovations, where people are first attracted by all the potentials, by all the benefits, where people are talking about. But then when they start to implement it, a lot of questions arise, especially for digital twins. Well, or it's especially difficult for digital twins because it's such a broad term. And as you said, it's quite hard to understand what is the physical aspect, what is the virtual aspect, and it's not a blueprint, as you said. So it's also, you can't have one answer for all digital twins. You need to assess it for each digital twin individually, and it will be different for each company. So that this makes it maybe hard to have a general level of trust in the technology or in the concept.
I think it was really interesting, these digital twin wheels that you did in the paper.
Yes.
I think it supported a lot of my understanding for a digital twin, because as you say, it has peaked, and you use it digital twin in everything now. It's also in cybersecurity, etc. Blah blah blah. So that's really interesting. Thank you very much for your answers. I will go to...
Thank you for your questions.
Rebecca.
Yes, thank you.
And also you have a very interesting proposal in your paper, because I think it's like 20 years I've said that we have to start to look into the organization and to the management and leadership, etc., when we talk about Industry 4.0 or digital transformation. And someone has actually coined the expression that we have Stone Age emotions. So that hasn't changed so much. We have medieval institutions, that's the organization, and we had godlike technology. And I think in Industry 4.0 there's a lot of smart things, but I never heard about the smart organization. So that's very interesting. You start from an assumption that there are unknown facets of Industry 4.0. And do you have any idea what those unknown facets could be?
Yeah, we basically, in management literature, we especially focused on technologies. So we well known how technology works, but we do not know how humans interact with this technology, and how the skills should change in order to benefit from this technology. So the unknown facets are somehow linked to the work of Stefan, because he focused on the role of human in these technical systems. So we have to improve the skills, of course, but also the interaction of the employee with this new machine and these new systems. So I think that the direction is to pass from Industry 4.0 to Industry 5.0, that is the new concept introduced by European Commission that focus on sustainability and human-centered systems in order to improve this interaction and the performance of the technologies. So the unknown facets are the interaction with humans, I think, mainly.
I think also when you talk about these unknown things, I think first I like to know for whom are these unknown things unknown?
Yeah. I think both for employees, of course, but manager also, and also for researcher. I think that technology is more in the future than us, so we have to go at the same level of technology. So we have to go in a deeper way to understand all of the facets of technologies and how we can interact with it. So it is unknown both inside the firms and outside, I think.
I think also for me, design theory is really big. It's huge, and Industry 4.0 is also some kind of huge perspective of a new wave of how we reason in industry. And Industry 5.0 doesn't make it easier. Do you have any delimitations for your study that you are thinking of?
Yes, I think that we are now focusing on human-centered systems, so to understand this specific focus, because if you think about Industry 5.0, you have both sustainability, responsible consumption and production, and also human-centered, that are all big topics. So if we focus on human-centered production, we can both reach social sustainable objectives, but focusing on a more specific topic. So I think that this is the line to follow to improve this direction.
I will pass on that one to Ross later on. I think that was a good one. But have you ever thought about, you have the question, can design theory be useful? What if the answer is no?
Okay, this is not so clear for the moment, because I think yes, but we have to, in this research, we only proposed a framework to implement and to apply design theory in practice. So we have not yet done this passage. So I think yes, because it allows to segment and separate the single aspects of the phenomenon in order to enrich our comprehension on Industry 4.0, but we still implement in practice. So the answer is to be discovered yet.
Yeah, hopefully it's at least a small yes, so you have something to do. But I also think that your proposal actually can show that the future of engineering will be even more complex. So it's not just the physical and what engineers are used to. It will be a lot of more perspectives coming in.
Yes, I think
so. Thank you very much.
Okay. Thank you.
Do you mind if I could ask Rebecca a question? Is that okay?
It will be a long discussion. I have to remember it. It's about education and human-centered. So, I mean, if you are going to design education for engineers for the future, how can I bring in the human-centered perspective? As it is right now, we are quite, the design thinking community is quite delimited to technical design or industrial design. But we need to bring it into mechanical design and all other types of engineering.
Could I ask Rebecca a question?
Yes.
Yeah. It was just quickly on the CK model that you mentioned. Was there anything unique about that model that made it appropriate for the problem, or could other models be used?
Sorry, I don't listen you well. Can you
Sorry.
repeat?
the CK model
Yes.
that you used, is there anything unique about it that made it appropriate for the problem? Or are there other models and frameworks you could have used?
No, we focus on CK model because it is, I think, that the most used in this field. I found other 2 studies working on CK model in Industry 4.0, and this is the main reason. So, but I think that also the other models used should be explored in this field. So it is not the best one or the unique, I think.
Perfect. No, I just wanted to ask. Thank you.
Yeah, and yeah, answering to the question before of Asa, I think that it should be implemented a transdisciplinary engineering, including also social and sociological aspects and management aspects and other disciplines other than all the engineering fields. So it is wider perspective, I think, but I have finished. Thank you.
Well, thank you very much. Thank you, Ross, for asking questions also. Matthias, you had the paper about open organization and open innovation, and all of these are described in research as leading to success. And you have this kind of descriptive framework, which I already think is useful because I plan to use some more parts of it in a new application that I will do. I think that was really interesting framework. But you know, in real organizations, when it comes to reality, making compromises, align interests, I mean, these are main challenges, and also being open is a main challenge because you have to be sort of as open as possible and as closed as needed because it's still business. Do you have any ideas for how to use your framework in a more, I already applied it, but in a more applicable way to for example, align interests, and how can we deal with these fuzzy human things by using your framework?
First of all, it's great feedback that you're already using it. And I would also be keen here to learn from your experience when you have applied it later on. I mean, yeah, openness, it's a really good question. Even in open innovation, open is more defined as a permeability. So it doesn't mean you need to be as open as possible. It really depends on, the project, the process, the people involved. So you need to be purposeful, what you open and how you open it. And it's kind of interesting because in the beginning, I thought I'm a bit the weirdo here in the session, but I can really see a lot of similarities between Industry 4.0 and open innovation, open organizations, because both concepts are kind of fuzzy. Everyone has a different understanding of it, and also depending on each of the companies, it can look completely different. So for one company, it can be fully open. Others are rather closed. The same applies to Industry 4.0. And even when we look at the findings of Rebecca, that SMEs or small companies would benefit most of Industry 4.0. There's a study from 2010 which has the same findings for open innovation, but they also find that although they would benefit most, they struggle most because they don't have the capabilities or the capacity, the resources to do it. We can also find the same barriers in adopting it. Of course, not 100% the same, but for example, Rebecca, I would find it quite interesting to look at it also from a champions or promoter model perspective in terms of, do the people have the ability or the knowledge to do something? Do they have the permission or do they have the motivation? So it's really quite interesting. I mean, coming back, so I'm a little bit doing some excursions here, but coming back to the question, would it also be applicable in an industry setting? I mean, the starting point of having this open organizational framework in a research center environment makes it quite easy because everyone likes to share knowledge. And it's really the purpose of sharing knowledge. Here, it really comes down how we do it in a purposeful way, because just putting 3 universities and around 30 researchers in a organization and just hope that they exchange knowledge, I think you can wait until the cows come home. Nothing will happen, or not very systematically. In an industry setting, I think to some extent we can see it in innovation ecosystems already. So it really comes down, in the end also to trust and probably some NDAs or IP arrangements. So I can't give you a clear answer here. I can only tell you it's like in design, it depends.
I like that one, and I like because I always say when I'm teaching, it always ends in "it depends." So I think you gave a really good answer, and I understand a lot more thanks to that.
But I mean, what I also can see, it's quite interesting with the linking to your previous question to Rebecca. That engineering is really becoming more complex, and it's not only about the technical side anymore. So as part of this research center, it's about collaborative robotics, and it's a really interdisciplinary team. And we're also looking, for example, in work health and safety risks for workers. And here we can also see that a lot of research, for example, is focusing on the technical side, but we also found that it's quite important to look at the psychological component and also the ethical component. So what does it mean if Industry 4.0 replaces your co-workers by a machine and you feel completely isolated? It also directly affects your motivation to adopt a new technology.
Yes, this is very interesting also because looking only at ergonomics, there are both technical aspects but also psychological one. So I think that interdisciplinarity is the new way, of course. And speaking about, I only 1 minute, about the small firms that reach higher performance that you cited before, I think that it might depend by the fact that specifically in our sample, small firms are very innovative startups that are small but very focused on technology. So they already have the skills inside. So it might depend by this fact.
Thank you very much. Ross, it's your turn now. I think really, I think the education part is very interesting, and especially the difference between large companies and SMEs. That's something I do myself also. And I like to see that you are doing this post-it template research. I do the same. I think it's very effective to get this kind of interpretations and experience from all the respondents. But you talk about the barriers as capacity to change and culture to encourage change and knowledge of how to change and justification for change. And I've learned in one of my courses that the only one that really want a change is a child with dirty diapers. Because you cannot always say that if you change something, it will be good for me, it could be good for someone else. I think these barriers are related to high order skills of education, some kind of personal development. Have you thought about how these mental barriers, how can we actually put them into education situation and make someone understand that they need to think otherwise?
Yeah, that's the big question, and it's the big question that the paper sort of proposes for the Scottish landscape. it would be interesting to see how other countries are dealing with probably the same challenges. Imagine larger countries have more of a strategic, implementation. And the way that it works in Scotland is that it's very much top down of this is where we want our manufacturing to develop and to move into, with a few interventions that really only those large companies are reaching out and utilizing. The small companies just don't have the time or the capacity or the knowledge to be able to do that. And so where we see the sort of intervention coming in is with these courses that we can deliver to the smaller companies, and also through just our knowledge network of our students who are leaving the university currently with knowledge of Industry 4 and what the future looks like, going to these companies and then suggesting solutions to problems that then the university can help with the implementation. It seems to be a very slow process, whereas with Industry 4, I think the vision is that it will transform the industry and it will be very easy to implement and fast to implement, and we all need to move at the same time. But that just doesn't seem to be the sort of case in hand, which is unfortunate. So I don't have a specific answer, but yeah, I think it's a slow process, is what I would say.
Irritating slow process.
Yeah.
I thought you had the answer for me.
No, unfortunately not.
No, but I think, do you have any suggestions for how to differentiate education for large companies and SMEs? SMEs, you said, was day-to-day.
Yeah.
And that's also my experience. They don't have a long horizon when they look into the future.
Exactly, yeah. And so we've worked with some smaller companies this year with one of our projects or classes called the Industrial Group Projects class, where 4 or 5 students are aligned with a company on a problem. And we've had a couple of management problems in there. And that's kind of the types of things that we need to do often, is to get our students or one of our early academics involved with a company to show them what are the potentials. We have sort of access guidance for access to funding that, again, we can align a student with the funding, with the company, to scope out what the potential is for that company. But it seems to be always, from our perspective, that it's the university who wants to support the company to move forward, and less so the company reaching out to us to say, we want to achieve this, which is a very odd position to be in with the number of companies that we work with. It is maybe a little bit unsustainable as well. We need a sort of bigger scale government-led or industry-led intervention to be able to support a lot of companies at once to make the move.
Yeah, I think it's a huge difference, and it was nice to read your paper where you actually put words on the differences. Yeah. I think that was nice. Thank you very much. And Stefan, now it's your last but not least. I think you're also talking about this strong entrepreneurial culture, and for me, that's a lot about trust, for example, and risk-taking, and attitudes of sharing and generosity, like openness. How did you select the companies for your study? Because I thought you based your selection on they have a strong entrepreneurial culture. It was not like that.
No.
Okay.
We just used the database of the research project Numia, which ended in 2019, and there's what random number of company representatives that can just assess for themselves their digital maturity degree, answering this catalog or survey. So we had no the company A or B can take part. So that was just a random sample.
Okay. Did you look into in this digital maturity? I don't know how to pose the question. How about leadership? You talk about and autonomy and participation, and how will that affect leadership? Do you know anything about that?
That's also for a top-down aspect, so that managers have to enable their employees to act and participate in making decisions, for example. So I think this is an aspect that has to be both top-down. But I think we already had a discussion about unknowns or not awareness of digital potentials on management level. I think this is the reason for this is because there are new roles such as a CIO or a CDO, so that the management just don't want to know about digital transformation or digital technologies in detail, so that they can just say, okay, that's the topic of our CIO or something. And this is, I think, very change where leadership have to change, so that they really do need to know some technological details about digital transformation.
Yeah, thank you. Yeah, you had a little bit of broken sound for me, but I hope I understood it right. So but I think you and Matthias has things in common. You should talk to each other, looking at the paper at least. Is there any question you have to each other before we close the session?
I have a short question for Stefan, if we have time, because I think that for firms, Industry 4.0 is already a big revolution, so something very difficult to do, in particular for small firms. Do you think that the focus on the role of humans is something that firms are ready to manage, or it is too difficult to manage technologies itself? And so
yes, I think larger firms are quite a bit further in their development stage of qualification approaches and qualification approaches to qualify their employees in a very precise in order to it is tailored on their role in the company. And I think this is something that misses in smaller firms. So I think smaller firms are very have to find their own way to qualify their employees, and this is quite more challenging than for larger firms.
Thank you.
So we have still 1.5 minutes left. If there is anyone else who has a question.
I don't so much have a question, but I would like to talk to, is it Jakob or Jakob further?
However you want.
So it was more about the implementation of your research, and if you've thought about what the implementations are for things like meetings and managing relationships, because it got me thinking about some research we do here on the topic of high value meetings and how to manage and things like that. In fact, the person who's doing that is doing a viva today, so it could be fortuitous to have a conversation as well. But I'll maybe message you after the session.
Yeah, it would be great. Thanks.
Okay. don't be surprised if I send an email to some of you, because I think we have more publication that we can share with each other, and I guess you have a lot of hints for me to do better research. So perhaps I will reach out for your advices. I would like to thank you all for a really good doing really good presentations in the videos, and thank you for your discussion, and thank you for your good answers. And I wish you a nice continuation of the conference. So let's quit, or rather let's close this session. So thank you very much. Bye bye.
Thank you very much. Bye.
Thank you also.
Bye.
Bye.